2.7, parallel lines and transversals. Parallel lines are coplanar lines that do not intersect. And those two vertical segment markings, those mean parallel. And I could write line AB as parallel to line CD without writing the word parallel if I use that symbol. Skew lines are lines that are not coplanar and do not intersect. So we'll see an example of what that looks like in just a second. Parallel planes are planes that do not intersect. So you'll see these a lot in 3D figures, such as this cube. So if I were to look at line AB and line EG, which would be here and here, I can see that they are not coplanar and they do not intersect, so they are skew. And then line FH and line ED would be here and here, and those are parallel, and you may use a parallel symbol for that if you want to, or you can just write the word parallel. So parallel lines. And then plane AGE, which we see on the front here, and plane BHD, which we see in the back here. Those make parallel planes. So you may be given lines or planes, and you may have to identify, are they skew, are they parallel? Maybe they're neither, maybe they just intersect, or maybe they're parallel planes if I give you two planes. Okay, transversal angle pair relationships. A transversal is any line that intersects two or more coplanar lines. So if I say these lines A, B, and R are all on the same plane, then line R is the transversal because it intersects line A and line B. When I give you a transversal, like here line T is the transversal that intersects line Q and line R, your interior angles are the angles that are inside your two lines. That's not the transversal. So I have that shaded in green. That's angles 3, 4, 5, and 6. Your exterior angles would be the angles that are outside the two lines that are not the transversal, like angles 1, 2, 7, and 8 that are highlighted in yellow. Corresponding angles lie on the same side of the transversal, so that would be line T, so the same side as in either the left or the right side, and on the same side of the two lines being intersected. So for example, angle 2 and angle 6, they're both on the right side of the transversal, and they're both on the upper side of the two lines. So another way to look at that is they're in the same corner. They're both in the top right corner. Angles 4 and angle 8, they're both on the right side of the transversal, and the bottom side of the two lines are in the bottom right corner. Angle 1 and angle 5, they're both on the left side of the transversal, the top of the two lines, or they're in the top left corner. And then angle 3 and angle 7, they're both on the left side of the transversal and the bottom side of the two lines, or the bottom left corner. So you're basically matching up one of your four corners. Okay. Next we have alternate interior angles. They lie on the interior, so in the green shaded area of the two lines, and on opposite sides of the transversal. So they're like on alternate diagonal corners on the interior. So that'd be angle 3 and angle 6, and angle 4 and angle 5. You can also have alternate exterior angles. They lie on the exterior of the two lines, so in the yellow shaded region, and on opposite sides of the transversal. So exterior, I'm only looking at yellow, and opposite sides, I would match up angle 1 and angle 8 would be alternate exterior, and angle 2 and angle 7 would be alternate exterior. You also have consecutive interior angles. Sometimes we see those called same side interior angles, but consecutive interior are on the interior of the two lines, so in the green shaded area, and on the same side of the transversal. So interior to my two lines in the green, same side, either both on the left or both on the right. So angle 3 and angle 5 are consecutive interior, and angle 4 and angle 6 are consecutive interior. Next, if I just wanted to identify some, my interior angles would be angle 3, 4, 5, and 6. My exterior angles are angles 1, 2, 7, and 8. My consecutive interior angles are angles 3 and 5, or angles 4 and 6. My alternate interior angles are angles 3 and 6, or or angles 4 and 5. My alternate exterior angles are angles 1 and 8, or angles 2 and 7. My corresponding angles, again, think of those as matching up one of the four corners in the two intersections. So angles 1 and 5, angles 3 and 7, angles 2 and 6, or angles 4 and 8. Corresponding angles postulate. This is a postulate, so it does not have to be proven. You get to assume that it's true and use it in any problem or proof that you want. The corresponding angles postulate says if two parallel lines are cut by a transversal, then corresponding angles are congruent. And this is extremely important that you focus on parallel lines. If you don't have two parallel lines, this is not at all true. So none of the other examples that you just saw where you named corresponding angles would have corresponding angles congruent because those lines were not parallel. These are. And you can tell that they're parallel by those solid shaded arrow markings that you see there on the line. Not the arrows on the ends of lines because we always see those, but an arrow actually somewhere on the line that match up, almost like congruent markings, but they mean parallel here. So I can see all sets of my corresponding angles are congruent. So we can use that to work out a problem here. If I tell you that the measure of angle 5 is 70 degrees, then I can go in and I can mark angle 5 as having 70 degrees. I could use the supplement theorem to tell me that angle 5 and angle 6, they form a linear pair, so they're supplementary. So angle 6 has to have 110 degrees. I can then use the vertical angles theorem to say 5 and 8, those angles are vertical angles and they are congruent. So if angle 5 has 70 degrees, angle 8 also has 70 degrees. Same thing, angle 6 and angle 7 are vertical angles, so if angle 6 has 110 degrees, angle 7 has 110 degrees. And then if I want to find the measures of angles 1, 2, 3, and 4, I can do that using the corresponding angles postulate. So 1 and 5 are corresponding angles, and here they happen to be congruent because I have parallel lines. So if angle 5 is 70 degrees, then angle 1 is 70 degrees. Angles 2 and 6 are corresponding, and since we have parallel lines, those are congruent, so angle 2 is also 110 degrees. Angles 4 and angles 8 are corresponding angles, and since I have parallel lines, they're congruent, so 4 is also 70 degrees. Angle 3 and angle 7 are also our last set of corresponding angles, and since I have parallel lines, they are congruent. So angle 3 is also 110 degrees. There are 3 other theorems that can and will be proven. If 2 parallel lines are cut by a transversal, then the alternate interior angles theorem says then each pair of alternate interior angles is congruent. The alternate exterior angles theorem says then each pair of alternate exterior angles is congruent. And the consecutive interior angles theorem says that each pair of consecutive interior angles is supplementary, not congruent. And so if we go back, we can actually see that that's the case. Angles 3 and 5 are consecutive interior and they're supplementary because I had 2 parallel lines cut by a transversal. Angles 4 and angle 6 are consecutive interior and they're supplementary because I had 2 parallel lines cut by a transversal. 1 and 8 or 2 and 7 are alternate exterior, and we can see 1 and 8 are congruent. We can see 2 and 7 are congruent because we had parallel lines cut by a transversal. Angles 3 and 6 or angles 4 and 5 are alternate interior angles, and we can see that 3 and 6 are congruent and 4 and 5 are congruent because they're alternate interior angles that are formed when 2 parallel lines have been cut by a transversal. Okay. Then we have the perpendicular transversal theorem that can also be proven. So if a line is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. If you were doing a proof on this to try and show me that, you would want to first know the definition of perpendicular. You would want to know that perpendicular lines intersect to form right angles. You would want to explain to me how a right angle has 90 degrees, maybe using one of your right angle theorems. You would also want to identify your corresponding angles and how they are congruent, and how using the definition of congruent, those measurements are equal. And so if they have equal measure, then one corresponding angle is 90 degrees and so is the other. And then you kind of work your way back and saying, well, if the other is 90 degrees, then it has to be a right angle. And if it's a right angle, then those lines have to be perpendicular to each other. And you can reason through that in a proof and take that step by step by step and give it justification for each one. Okay, so here's an example problem. I have two parallel lines that have been cut by a transversal. And I want to find the value of x and I want to find the value of y. And one of the first things that I notice here is that I have corresponding angles that are congruent. So that means that 3x minus 15 has to equal 105 degrees. And I can work through that problem and I can solve it. I can add 15 to both sides, get 120. I can divide both sides by 3 to get x equals 40. And so if I wanted to find the value of x, it is 40. I also see that I have a linear pair formed by 3x minus 15 and y plus 25. And if I have a linear pair, then I know those angles that form that linear pair are supplementary, or they add to 180 degrees. So 3x minus 15 plus y plus 25 equals 180. Now I already know that 3x minus 15 right here is 105 degrees. So I can go ahead and substitute in that 105 degrees and make this problem a little bit easier. And if you didn't see that, that's okay. What you can also do is take the x equals 40. You can substitute 40 for x, and then the 3x minus 15 will end up being 105 as well. But it's a lot faster to just say, hey, all of that together was 105 degrees, and so that makes your problem a little bit quicker to solve. Go ahead and combine like terms. So I get y plus 130 equals 180. Subtract 130 from both sides. So y equals 50. So that's finding your variables. One good way to check your work is to substitute those values back in. So if I substitute in a 50 for y, I get 50 plus 25, which tells me this angle right here is 75 degrees. And if I substitute 40 back in for x, then I get 120 minus 15, which is 105 degrees. And if I were to add 105 degrees to 75 degrees, I do get 180 degrees, which is what that linear pair has to have those measures add up to be. Okay, one more example. I want you to find the value of x. So one thing that you're allowed to do is you can construct a line that is parallel to any other line that you already have. So I know that there exists some line through here. That is parallel to those other two. And then I can look and I can see, hey, if this has constructed a line, if I have constructed a line that is parallel, then this 50 degrees is a corresponding angle to this angle right here. So it also has to be 50 degrees. And then I can see that this angle right here is 100 degrees. If I wanted to find this angle here, I know that I have two parallel lines cut by a transversal, where those are consecutive interior angles that have to be supplementary. So if one is 100, the other one has to be 80 degrees. And then if I add those two measurements together, I can find x equals 130. Or since that is in fact an angle, I can see the measure of that angle would be 130 degrees.